we doing out there? There's a lot of you. I mean, I kind of saw you coming in, but now that I look at you all at once, it's there's a lot of you. There's a lot of brain power here, and that is so good to be around. As Margie told you, I'm Whitney Prats. I work for the Planetary Society, and we are so excited to be here to kick off this conference with you. We love this conference. Who doesn't, right? Yeah. The Planetary Society's mission is to empower the world's citizens to advance space science and exploration. We do this by educating, advocating, and creating space science and exploration projects. Up until now, our education efforts have mostly involved our public outreach, including blogs, a quarterly journal, our radio show, and our website. But within the last year, we've been developing a youth education program to truly own that education pillar of ours and to get into classrooms. So what we're doing here this year is trying to build a network of teachers who want to help us build the best education program we can. And we don't know how to do that without teachers. So we're here building what we have called the STEAM team, hashtag STEAM team. And what better place to do that than Music City Center? I mean, it all is kind of coming together. But, so let's see. If you want to ask Bill a question during the Q&A later in this show, please tweet using the hashtag STEAMTEAM, STEAMTEAM. We all know how to spell that. And I'm going to do a quick demonstration at our booth. We have a booth this year for the first time, 1012-1012. We're giving away foam asteroid stress balls. They're very I only brought 2. I'm a little embarrassed with how many of you are out there and how far away you are, but this will be good. It's going to be great. I just want to demonstrate to you how harmless they are. Who wants one in the front row? Let's see. Oh, see, bouncy, easy, harmless. Let's see, who wants one over here? Okay. Bouncy, safe, and awesome. Please come get them at our booth, 1012, to get asteroids and also to join STEAM Team. We need a network of teachers who's excited to engage with us, who's excited to build this youth education program with us because we want to create a product that you will actually use. We want to understand how we can get space science into classrooms at least 30 minutes a week. And we don't know how to do that without you. So please come join our team. It's Bill Nye's STEAM team, and we are going to be so excited to talk to you at booth 1012. And by the way, by the end of this show, as awesome as those asteroid stress balls are, you are going to understand why the Planetary Society we do not recommend giving those to your students. And without further ado, let's get a little warmed up here for the main man. I want this side of the room to say Bill in your warmest, loudest voice. Ready? Yeah. Let's have the center do it. Yeah. This side. Yeah. Okay, everyone. All together, please help me welcome my favorite human to this stage, Bill Nye, the science guy.
Whitney! Oh, Whitney, my dear. Thank you. Whitney works for the Planetary Society. She's the brains. Greetings. Hello, Nashville. Woo! Oh, it's so good to be. I know I've been to Nashville many times, but this is the first time we've had the NSTA here. Very exciting. It's great to see you all, and I'm very happy that, as I understand it, I've been teaching a lot of your classes this year. Or a younger version of me. So we do hope you check out the STEAM team. We were going to call it the STEM TEM, but it just didn't have the right vibe. No, so let's get started, shall we? So I like to say, at the Planetary Society, there's 3 things. We do 3 things. First thing is we advocate. We have people that go to the U.S. Congress and petition congressmen and senators to do the right thing, to support space science and exploration. Oh, yes, thank you. No, I just want to say, no, thank you, of course, yes, thank you. But you will find, I don't want to shock you, but you will find that not everybody agrees on what the right thing is. But as is so often the case, my opinion is correct. So then the second thing we do is we create, and I know some of you out here were members. Thank you all. We, this year, fulfilling a dream of Carl Sagan's from 39 years ago, we flew our own solar sail spacecraft, built by people like you. Thank you. This is exactly the same technology. It's a CubeSat, the same technology that many of your students, I'm sure, are engaged in. And the third thing I like to say that we do is educate. We advocate, we create, we educate. That's what we do. And what we want to do this coming year especially is emphasize our education. Now, for those of you unfamiliar, the Planetary Society was started by three guys: Carl Sagan, an engineer at the Jet Propulsion Lab, JPL, Lou Friedman, and the head of the JPL at that time, Bruce Murray. Those three guys started the Planetary Society, and Bruce Murray was the head of the Planetary Society during those heydays when landed spacecraft on Mars for the first time and built the Voyager 1 and 2, which are on their way out of the solar system. So those are the guys that founded us. For those of you who don't know, I had, by some remarkable mistake at the admissions office at Cornell University, I went to Cornell, some sort of clerical error, and then something else went wrong, and I took one class from Carl Sagan. And when you do that, you get on the mailing list. And I see some of the sort of younger teachers here. There used to be technology where they would send you, it was paper, we called it paper, and you could store information outside of your body, and they would leave it at your house. It was crazy. It was before the internet. And so I joined, and I've been a member ever since. And then you guys all know Neil Tyson, who spoke in here. He's on the board of the Planetary Society, and that's where he and I met. And I don't know if you know this, he's really into wine. He's quite the enologist. And something happened 5.5 years ago, and now I'm the CEO. I really am not clear on what went down. But just to go over some things, I'm going to talk just briefly again about me. And then I want to take it up to where you guys are going to tell us what we should be doing. So when you look at the Science Guy show, we whimsically divided all of science education into 3 categories: life science, physical science, and planetary science. And when you use the word planetary science, it becomes inclusive. It can be astronomy. It can be earth science. You can be talking about dinosaurs. You can be talking about plate tectonics. You can be talking about ice on other worlds. You can be talking about radio astronomy and radioactivity and everything. Then physical science, we just said physics and chemistry, the study of motion, the study of chemicals, elements. And then planetary science was astronomy and earth science. And having this structure, start with 3 things, expand to each of the 3 things, that led to us being able to create all 100 shows. 100 shows. 22 years ago. It just about killed me. But I really appreciate your support all these years, everybody. And so I tell this, no, thank you. Oh, wow. Thank you. Thank you. No, I tell this very brief few sentences story often enough, but at my 10th college reunion, I was starting to work in television, and I wanted to do a kid show because I felt the U.S. at that time was headed for trouble. We had products like the Ford Pinto, the Chevy Vega, and so I was a mechanical engineer. I mean, I'm human, but I was a mechanical engineer, and I went to Carl Sagan's office. It was a big to-do to get his assistant to let me meet with him for 5 minutes. Maybe it was less than that. And I described to him what my ideas were, and he said, just stop yourself, focus on pure science. He said, the verb he used, kids resonate to pure science. And so I took that to heart. And I think a lot of the reason that these shows have stood the test of time is because we didn't get off on technology hardly at all. And so while but anyway, that comes from Carl Sagan. He was an inspirational guy. And while we're here with the Ford Pinto, I would just like to talk briefly about a big idea. The Ford Pinto, for those of you who didn't get involved with it, was kind of a bad car. I circled here some design defects. And I don't know how many of you are familiar with it, but it was a front engine, very small car. There was a lot of empty space in the engine compartment. That's the way Detroit was thinking at that time. It was rear wheel drive, and it was also rear gas tank. So it had this really undesirable feature that if you rear-ended it, it would explode. And that you don't really want that in a car. There are certain action films, maybe the occasional James Bond movie, you want to rear-end and have it explode, but day to day, it's not really the thing. And I don't know if you know this, but this is a real detail. The Ford legal department did an analysis. Engineers said, hey, the gas tank's really in a bad place. If you hit it, it cracks and gas gets on the very hot tailpipe, and it often leads to this catastrophe. And the legal department said, no, the price of the lawsuits will be cheaper than moving the gas tank, which was often estimated, I mean, you hear different numbers, but it was less than $5, $3, to redesign the gas tank. But they planned to sell millions of these vehicles, and so, I mean, what could go wrong? It led to at least 7 deaths. But for me, there's a big lesson. Now, I'm of a certain age. There's a big lesson to be learned from this. And this is what I like to refer to as the upside-down pyramid of design. Now, for those of you who are into curls and partial derivatives and multi-dimensions, this could be the del. I don't know if you know that symbol in mathematics. But you start at the bottom of the pyramid with the design. And the design is often very few people. When we did the Science Guy show, for example, there might have been 6 of us. There were 3, really. It was Jim McKenna, Aaron Gottlieb, and me, and I. And then a couple other people, Ian Saunders, who now works for Bill Gates, and Bill Sleeth, who's now the head of architecture for the Starbucks Corporation. And we talked about what the show would look like for a long time. We worked on the design. And then we agreed on it. And if you're making a car, it's the same thing. People agree on the design, not exactly the same thing as making a kid's show about television, about science. You can tell them apart. You can tell the kid's show from a car. Most people can. You start with a design, and then in auto manufacturing, you have these whole bunch of people called quality assurance and material planning. When you make a car, you got to buy steel from somebody. How much steel do you buy? When does it have to be delivered? You have to buy welding supplies and paint and upholstery and all kinds of copper wiring and taillights and lenses and all this stuff. So that's material planning. And then you have welding and painting. And then you assemble the car. You assemble it, and then at some point there's this mythic layer called marketing. I don't really know what goes on there, but they generally spend more money on marketing than they do on the car. I know you're shocked to learn that, but and then there's sales, and then eventually you get a car. Now here's the thing. You can have the greatest welders in the world. They can come to work every morning and do calisthenics and sing the welding song. Yes, we're going to weld cars today. I don't really know how it goes, and then you can have the best auto body painters in the world. You can have the best upholsterers, the best electrical wiring fitters. You can have all these guys, but if what you start with is a Ford Pinto, the very best you're going to get, the best you can possibly do on your best day, say Tuesday morning, that's supposed to be the best day in manufacturing, is a Ford Pinto. That's all you're going to get. So I just encourage everybody, every time you go into any endeavor, whether you're designing a curriculum, a demonstration, a test, whatever it is, spend as much time at the beginning as you can. So with that said, the Planetary Society has a few small things from which we build. And I want you all, I very much appreciate you all thinking about these things and telling us what to do. We'll have a booth tomorrow, and check us out. It'll be big, stupid fun. The first thing, which is part of our mission, is to know the cosmos and our place within it. I feel that everybody who takes the time to understand that we are on a planet orbiting a star, just like all the other stars you see in the sky, I think that is profound. It affects you deeply, how you feel about what I like to call your place in space. And don't tell me it's not important, because everything you're wearing came from some other part of the world, with a few exceptions, a few cotton t-shirts. And that is enabled by navigation across the trackless ocean, which we have because we discovered that Copernicus discovered that the Earth is orbiting the sun and so on. So this is a very important insight. And just before we go, does everybody see us there in the picture? There, that's easy, and I mean, it's obvious right there. But this gets into these two deep, deep questions. I say this all the time. There are two things that everybody asks him or herself from, well, I guess before kindergarten, preschool. And I continue to ask these two questions throughout my whole life. I'm no longer, people might suspect I'm in kindergarten in some ways, but I am a grown-up paying taxes. So where did we come from? How did we all get here? And this, for me, of course, is part of the process of evolution. But it's also sort of philosophical. It's deeper than that. Like, you get into this question, why we're here, or how did we get here? Are there other places with things like us? And so another thing the Planetary Society is deeply involved in is the search for life. Because this is addressing the second huge question for me, which is, are we alone in the universe? And everybody has wondered these things. My claim is that if we were to discover life on Mars, or Europa, this moon of Jupiter, or receive a signal from deep in space, a radio signal, the spiritual equivalent of the Dick Van Dyke Show from outer space. I'm talking about an old TV show. More importantly, the Big Bang Theory, that's from somewhere deep in space. It would change the world. It would change the way everybody feels about being a living thing in the universe. And the third thing that's very important to me is we want to prepare humankind to deflect an asteroid. And I'm not kidding. I mentioned this at TED one time, you know, that fancy speech organization. And the people laughed. Asteroid. No, I'll tell you, here's why. Because that would be bad, okay? That would just be really bad. You know, when I was young, Mrs. McGonigal, my second grade teacher, read to us from a very impressive looking book that the reason the ancient dinosaurs disappeared is because they had small brains. So then the mammals took all the dinosaur food and they died. And even she knew that that was just lame. I mean, for crying out loud. You know, I mean, there's a rabbit here, and I'm a Tyrannosaurus. I mean, here, like this. It would just be, you know, and she knew there was trouble. So it was in my lifetime, everybody, through astronomy and geology, that people discovered that the Earth must have been hit by a very large impactor, rock or comet, that spread so much dust in the air that the place cooled off for so long it finished off the ancient dinosaurs. They may have been having trouble with sulfur before that, but they were definitely traumatized on that day or night. So with that said, I strongly believe that you can teach almost anything from the perspective of space science. And this is something I just want you all to consider, and this is where we'd like your help. I claim you can teach physics and chemistry, you can teach biology, and you can teach the method of science, how you design an experiment to test a hypothesis, and you can teach politics. You can teach just about anything from science, because from space science, because there's a lot of politics in space, let me tell you. And the other thing that I find so wonderful about space science and so important is it's inherently optimistic. Space science brings out the best in us. You may recall, for those who've come to my talks before, last year I showed this artist's rendering of Pluto. And in the foreground, the artist depicted the New Horizons spacecraft. I went to Cape Canaveral on 19 January 2006 for the launch of New Horizons. For those of you who are not hip to this fabulous detail, the astronauts who went to the moon took almost 3 days to get there on Apollo spacecraft on the Saturn V, the largest rocket anyone's ever built. The New Horizons spacecraft, a relatively low mass spacecraft on a relatively huge rocket, got across the orbit of the moon in 9 hours. After that, it got a gravity assist from Jupiter. It sped up even more a year later. And so even with that, the fastest rocket anybody's ever launched, with sped up by the orbital motion of Jupiter, it took 9.5 years to get to Jupiter. So there were people who believed in this. In the year 2000, I went with, that's my old best buddy, Jim Cameron. I met him. Okay, I met him. No, James Cameron met me. That's what it is. James Cameron met me. Then the woman seated there is Barbara Mikulski from the state of Maryland. Any Marylanders here? Woo! Right on. And she is very supportive of space exploration, and that's me as a much younger man. And that's Lou Friedman, the engineer from the guy. He had a PhD from MIT in celestial mechanics. And we went to Barbara Mikulski's office and said, we had 10,000 postcards from people like you. People want a mission to Pluto. And sure enough, everybody, this summer, on Bastille Day, we got pictures of Pluto. I mean, if you think about it, Alan Stern, who is the principal investigator on this, the PI, he was fighting for this mission in the late 1980s. Took him over 20 years to get this done, but how cool is this? Everybody's wondered about Pluto. Is it icy? Are there Plutonians running around talking Plutonian? What does it look like? So it took years and years to get these photos, and there are more coming down for another 1.5 years at least, maybe it's 2 years. And there are at least 7 geologic regions. It has an atmosphere, all these extraordinary things. And the more we learn about a world like this, the more we learn about ourselves, because the more we learn about the solar system and the cosmos. And this gets to a thing that is deep within us. Why does Pluto look like that? Why is it a ball? Why does it have craters? Why does it have nitrogen volcanoes? And just looking at this picture and comparing it to this one, this is Europa, the moon of Jupiter with twice as much seawater as the Earth. Now, if you have seawater for 4.5 billion years, it is not crazy to suggest that there's something alive there, or at least there something was. And I hope in my lifetime we send a mission there, a spacecraft there, or a group of spacecrafts, or a crazy complicated system of spacecrafts, and look for signs of life. Public interest in this is higher than ever. The reason the Planetary Society was started back in 1980 was because those guys felt, Sagan, Friedman, and Murray, felt that public interest in space exploration was very high, but government support of it was not. And so The Martian was a hugely popular movie, and the book is great. If you haven't read it, I suggest reading it. I know a woman who has a huge crush on Mark Watney. not on Matt Damon, on the fictional guy. And I got to tell her, there's no such, I'm sorry, he doesn't exist. But she's looking for him. And of course, when you look at this poster, I hope you were as bewildered as I was. 140 million miles. I see. Oh, you mean 225 million kilometers? Oh, just say it. Jeez. Yes, everybody, we look to the day when the U.S. embraces the metric system. Yes. And I'm not telling you know nothing, employing a triple negative for comedic effect, but doing any sort of chemistry, physics, biology, anything is so much easier in the metric system. 32.2, what? Well, of course, there's 7,000 grains in a pound. Oh, that's great. Wow, cool. And that's the foot, that was the king's foot. Oh, cool. Why did he have 5,280 of them? What was that about? I don't know. So everybody here was alive this last year when scientists using orbiting spacecraft, orbiting above the surface of Mars, have satisfied themselves that at one time, liquid water flowed on Mars. Everybody, it flows every year on Mars. Every Martian year, every summer, water weeps out of the craters of Mars. My friends, people. That's right, Mars. We've landed a lot of spacecraft on Mars. We have a lot of spacecraft in orbit around Mars. There's another rover scheduled to go in the year 2020, and we at the Planetary Society are advocating heavily that we drive up to one of these things and sniff around. Yes, we must protect the planet. You cannot violate the Prime Directive. Yes. You cannot take earthbound microbes and take them to Mars. But if you want to sterilize something, get it totally dead, I recommend putting it on the surface of Mars. It's freaking cold, and it's hit with ultraviolet light all the time. I mean, it would kill anything that we've thought of. So we really hope that the next missions go there. Meanwhile, the European Space Agency has just sent the ExoMars spacecraft to Mars, and it has the trace gas analyzer, and they're hoping to sniff around for methane. Now, it's possible that methane comes from comets. There's a chemical process that brings methane from comets, and it's possible that there's other geologic processes. Just heating and cooling the flow of steamy water in ancient times could produce methane that's flowing with certain minerals. But here on Earth, if you want methane, you get microbes. That's where you get it. And so if there are these puffs or plumes of methane on Mars, which have been detected by the Curiosity rover spacecraft, it is not unreasonable to me that there's something still alive on Mars. Some sort of Martian microbe, some Marscrobes of some kind. And the thing to remember about the European Space Agency, it's 16 countries that got together and built this thing and launched it, and they're sending it to another world. And this is evidence of international cooperation, which is another wonderful thing about space exploration. Now here tonight, a member of the Planetary Society, our volunteer coordinator, Kate Howells, is here, and so a little tip of the hat to Canada. If you have a Canadian $5 bill, right on. They celebrate the space program on the back of their money. Let's do that, people, because it brings out the best in us. And I presume the guy in the spacesuit is Chris Hadfield, the astronaut. It's hard to tell in this view. Anyway, it's just something that we hope that there's stamps and money that celebrate space. So I was in college. I was in engineering school back in 1976 during the disco era. Some of you may remember. You might have been kung fu fighting. You might have been working at the car wash. You might just have been doing the hustle. So Carl Sagan presented this idea to Johnny Carson, who was the host of The Tonight Show before Jimmy Fallon, before Jay Leno. He's the revered guy, the host of The Tonight Show, and he talked about a solar sail. This would be a spacecraft so low mass, with such a large surface area that it'd be pushed through space by the pressure of photons. Photons have no mass, Bill. Dude, what? They still have momentum. They're pure energy. It's crazy. So here's an artist's rendering that I presented to you all who were here or there in Chicago last year of our spacecraft in space. And here's the picture we got this summer, the real picture taken from the spacecraft. Those are the real sails deployed in orbit. And this is a wonderful thing because anybody in the world can participate. We have about 46,000 members who sent us money, who thought this was cool. We built the spacecraft and we realized Professor Sagan's dream 39 years later. Now, solar sails, so this was a demonstration flight. We're going to fly another one probably in November on the Falcon Heavy, the SpaceX, the next version of the SpaceX big rocket. And solar sails have specific missions that they're ideal for, as well as flying around and being cool. And some of them would be to have orbits that would otherwise decay, to be too close to the sun to stay in orbit, even with the Earth, in station keeping with the Earth, unless they had something holding them out. And a solar sail might be ideal for that. Also, it's reasonable that you could wrap a solar sail around an asteroid, and the reflection of sunlight would nudge the asteroid just enough to keep it from hitting us. If you had an asteroid this close to the Earth, it'd be a big one. It would be really bad. The Earth is hit with, I guess it's 100,000 tons of dust every day. Maybe it's every 12 hours. It's a lot of cosmic dust that hits the Earth, but it's the big ones that concern us. So if there were an asteroid coming, everybody, what would you do? You could, of course, run in circles screaming. That's generally ineffective. People try it. As you meet people in Congress who have that idea, but we are looking for real ideas. And let me tell you, if you want to get students excited about space, ask them how they would deflect an asteroid. We have a big rope. Okay, cool, all right. So there's some ideas, if I may, floating around out there. And one of them is to grab an asteroid and then give it a push with an impulse motor that uses xenon. Now, I know many of you carry xenon with you in your flash cameras, but this would take an enormous fraction of the annual production or collection of xenon, and that's the real limitation of it. If you put so what you do is you get solar panels to make electricity, a big tank of liquid xenon, you let it vaporize, and then the electricity is used to strip the electrons off, and then you have a grid like a window screen, and the xenon atoms go shooting through, except it's in space. They don't make just, they go through the screen, and then they have, although they're very low mass, each atom, they're going so fast, they have a lot of momentum, and this would nudge the thing. The limitation of this scheme right now is fuel. It'd be hard to have enough xenon, or whatever you're going to, argon or some other cool thing, out there in space to give an asteroid a nudge. Now, the whole idea, everybody, is not to push it really hard. You just want to give it a nudge, just a gentle nudge for a while, maybe years, so that you change its course. The whole thing is, by the way, you don't want to send Bruce Willis. Okay? You don't want to blow it up, because then it's possible that you'll have a bunch of fragments that are on an even more unfavorable trajectory. So you want to, so when it crosses the Earth's orbit, we're not there. That's the big idea. So the planetary side has been messing around this for a long time. The laser bees. So these would be spacecraft with solar panels, and they take electricity and make lasers. And we beam it at the asteroid. Zzz, except it's in space. There's no sun, just be. And the dust, the stuff coming off the asteroid, would give it a nudge. And we've tried this in this lab, in these labs, in vacuums, and it does have momentum. It's very cool. Where do you get these spacecraft? How would you coordinate them? It would be like cell phones, a network of cell phones. If one of them's working really well, you'd use that one more. If one of them's not being so effective, you'd move it, and so on. And these things could get out there on solar sails. Another idea that seems obvious is you'd put a rocket on the surface of the spacecraft, and then you turn on the rocket motor, except it's in outer space, there's no sound, just. But it's really hard to carry enough fuel. It's really hard. And the whole thing those guys are into, people who are into asteroid deflection, of course, who isn't, but is to have enough delta V, enough change in velocity. That's the big deal. So this is a cool problem we really want your kids to think about. Now, with all that said, doesn't everybody want to go to Mars? Who the heck doesn't want to go to Mars? Now, there are people who want to go there and not come back. Well, in fact, I have a few people in mind for that. But my old boss would be a good example. But that's really crazy, you guys. I'm telling you. There's nothing to eat. There's very little water. And you'll notice this right away. There's nothing to breathe. There's no air. You take off your helmet and then you're dead in a few moments. So the Planetary Society has proposed, we did a very diligent study. We brought in the world's foremost authorities. And we looked at this, and we could send people to Mars in orbit in the year 2033. And these experts created what they call the mission architecture. How many rockets, how big are the rockets, how often do the rockets have to fly, how much money would it cost? And we could put humans in orbit around Mars in 2033 without increasing the NASA budget, just adjusting it for inflation and sticking to the deal that we've all agreed to and signed contracts that that NASA, the US government, would stop being the leader in maintaining the International Space Station, which costs about $3 billion a year, which is a bargain. But there's a lot of companies that are interested in taking it over, and that would be quite a cool thing. So along this line, there's a fundamental, deep lesson to be learned from planetary exploration that I want all of your students to be aware of. And this is something I'm really concerned with personally this year. Let's say this picture of the sun represents the sun. And then, am I going too fast? And then this picture of the earth represents the earth. Okay, cool, all right. So the earth is one astronomical unit from the sun, and it's easy to remember an astronomical unit. You just go up to an astronomer and you say, "Hey, you, how far is it from the sun to the earth?" And he or she will turn around and say, 1 AU. And then there it is. So the Earth's an astronomical unit on average. Mars is about 1.5 times as far away. Mercury is only 40% as far. And Venus is 70%, 0.7%. And it was Carl Sagan who coined the phrase comparative planetology, comparing one planet to another. The study of a planet, not just of an environment, not just of the Earth, but of any planet. And it was through this that we discovered global climate change. For those of you who like to worry about things, you're living at a great time. The year 2015 was the hottest year on record. And the people that dispute that, I'm up here to tell you, are wrong. 2015 was the hottest year on record. And this investigation really started when people landed spacecraft. It started in the modern era, which is very important, in the modern era, when people landed spacecraft on Mars. This is a picture from Mars taken in July of 1976 by Viking 1. And we discovered or proved that the Martian atmosphere was only 7 millibars of pressure. That's 0.7% of the Earth's atmosphere, not even 1% of the same pressure on Earth. And millibar is an old unit from before the System International. And so the modern unit, as you may know, is a hectopascal. So how handy is that? But I'm hoping we change that to HEPS. 7 HEPS. Yeah. Low pressure. So Mars has very low pressure, has very little atmosphere to keep it warm. The atmosphere apparently was stripped off by the solar wind, particles from the sun, because it doesn't have enough gravity to hold the atmosphere on as strongly as it's held, for example, on Earth. And so over the millennia, over the billions of years, the solar wind stripped most of the air off, but there's still a little bit, but not enough to keep it warm. It's spectacularly cold there. It might be 0 degrees on the very surface, 0 degrees Celsius on a summer day, right? It's freezing right here. And then here it's 20 below, and up here it's 40 below. The gradient's very strong. And then on Venus, these are from Soviet spacecraft in 1984, I guess. Might be 85, excuse me, Venera 14. The pressure there is 90 times the pressure on Earth. 90 Earth atmospheres, 90 HEPS, 90,000 HEPS. It's hot enough to melt lead. If you went there with your fishing weights, they would melt. And it's 460 Celsius. I mean, it's really hot because the Venusian atmosphere holds in so much heat. And that Venusian, by the way, is the adjective for Venus. We had to coin that adjective because in the 19th century, things having to do with or pertaining to Venus were venereal. So we had to phase that out. Now it's Venusian. But when you compare Mars to Venus, to the Earth, you make this extraordinary discovery about our place in space. The Earth's atmosphere is fantastically thin. If you had a car and you could drive straight up at highway speed for an hour, you'd be in outer space. So that's the problem, everybody. The atmosphere is fantastically thin. It's like the varnish on a globe, as the old saying goes. Now, I am so old. How old are you? I'm so old that I went to the World's Fair in New York, New York. The town so nice they named it twice. Back in 1965. And the United Nations had a total board, a totalizer board of the world's population. And at that time, it was under 3 billion. We just missed it. My brother, sister, mom, and dad, we just missed it, changing from 2,999,999,999 people on Earth to 3 billion people. That was when I was 9 years old. As of this morning, we have 7.3 billion people. 7.3 billion people, all trying to breathe and burn this thin atmosphere. In my lifetime, the human population has more than doubled, substantially more than doubled, 30% more than doubled. And so these two things, the thin atmosphere and the huge number of people, is how this humankind has been able to change the world. So I just want to emphasize, talking some more about me, that I've been into this climate change thing for a long time. Because Carl Sagan talked about climate change when he realized that you could have a nuclear exchange so big that you would create a situation like the ancient dinosaurs' impactor, asteroid or comet. And so I've been fighting this fight for a long time, and I claim it's worth fighting. And furthermore, as you may know, it's very stressful, fighting this fight. It's so stressful, I had to see a therapist. And so I went to see Dr. Arnold Schwarzenegger. We did a show on National Geographic, you guys. It was really cool. Arnold Schwarzenegger is a very conservative politician. He has a bust of Abraham Lincoln in his office, a bust of Abraham Lincoln, bust of Ronald Reagan, and a bust of himself in his office. And so he is nevertheless very, very concerned about climate change. And we did a bit, and it was funny. And I said, he said, you are suffering, he talks that way. You are suffering from climate change denial. Climate change denial. And I said, climate change denial, that's not even a thing. It is a thing. And it was really funny, and I don't know if any of you saw it, but one thing led to another, and I got to say, later in the show, I got to say, "I'll be back," which was, come on, that was a high point. That was huge, huge, huge. Then, just to give you a very brief update, I did this debate in Kentucky 2 years ago. Thank you. Thank you. Thank you. And I know I've met many of you who used this debate in class. Thank you. Well, you know, of course, as a mechanical engineer, I'm an expert in evolution and debating. But I will say the stuff we debated was not especially advanced in science. There's a little bit of algebra. But what's interesting to me, and I circled it there or ellipsed it there, 5.2 million people have watched this thing. Are you telling me there's that much doubt about the main idea in all of life science? Heavens. By the stars. That is serious biz. So if any of you are among the 5.2 million, thank you. Turn it up loud. And don't worry, the next day, right here in our beloved state of Tennessee, not just over the border, was Bill Nye the Science. Yeah, if it weren't for Bill, you know, everything would be fine. But that picture was all over the internet the next day. And then for those of you who don't know, these guys are really diligent about this. This is from their curriculum materials. The answers in Genesis curriculum materials. Natural selection may bring about a new species of animal, but cannot generate a new kind of animal. Well, let me give you a comment about that. It's wrong! For crying out loud. So we have a lot of work to do. Now, this debate led to, there was at the end of it, for those of you who are not among the 5.2 million, at the end, or near the end, there was a question and answer where people in the audience wrote questions, and then this guy, Ken Ham, and I answered them. And really the essence of the scientific method, the whole idea behind critical thinking, was crystallized by a question from the audience. And the woman who crafted that question is here tonight. Tracy Moody, who is a journalist and an illustrator, wrote this. Look at her handwriting. It's fabulous. What, if anything, would ever change your mind? And I don't know if you remember this, but Mr. Ham said, nothing. Nothing would change my mind. Wow. Dude. So imagine this guy's on a jury and you're accused of something, a parking ticket or something. Nope, changed my mind. I'm good. We don't really need to have this trial, Your Honor. Actually, we do. That's part of the process. So if you don't know him, he's also notorious for making remarks. NASA is wasting a lot of money looking for alien because it's really evolution. Yes, if we didn't have evolution, everything would be fine. And another one of his things is, the Earth is now cooling. No, it isn't. And we are living at a fabulous time with all these amazing climate deniers. Hold it, did I mess that up? Hang on. They're all coming in, right? Did I mess that up? Or mess it up even more? Yeah. This is, there they are. I don't know if you're familiar with everybody, but of course there's Sarah Palin. There's Inhofe from Oklahoma who thinks if he found a snowball, there's no way the Earth could be getting warmer. Scott Walker from Wisconsin will not talk about evolution on camera. And Florida Governor Rick Scott will not permit anyone on his staff from saying climate change in a meeting. Okay, that's great. That'll fix it. And then here in Tennessee, we have our own Marsha Blackburn, who just is not into it. Then, you guys, I'm not going to tell you how to vote. It's not my thing. I'm not going to tell you how to vote. But keep in mind that on the Republican side right now, they are all climate deniers of various degrees. John Kasich says, well, I don't know, maybe. And our fascinating Donald Trump is mostly not believing in climate change, been very outspoken against it. And then, of course, Mr. Cruz is adamant there's no such thing as climate change. Well, along this line, I'm very excited to tell you that yesterday I was in New York City and I met with Mark Morano, who's this infamous, notorious climate denier. He's on conservative radio and television quite frequently, and he wanted to interview me about his movie. And we talked for quite a while, and it just became very clear that his perspective of the world is just wrong. So this is from a very well-known organization called Skeptical Science, and so that's the surface temperature of the world on one axis and time along the x-axis, as is traditional. And if you look at it, these data are still pretty accurate. I mean, they're still very robust. They're surface temperature data. So these are from 30 years ago. And if you draw a line through them, everything looks fine. If you look over a short time span, everything looks fine over a short time span. Everything's great over a short time span. But after a while, everybody, the world's getting warmer. Like, dude. So this graph was published very recently. This is where they took the Goddard Institute for Space Studies, for Space Science, the Hadley Climate Research Unit on Temperature, the National Oceanic and Atmospheric Administration, the Remote Sensing Systems Company, and the University of Alabama, Huntsville, and that all of these models get the same answer. Like everybody who's looked at this independently gets the same answer. So deniers, you got to get over it. And keep in mind, it's hard to track. The deniers have they want to be called doubters. The doubters have a extraordinarily complex way of funding their activities. And you may have heard last October, the New York Times found these documents from Exxon, before it was ExxonMobil, from 1977, showing that the scientists at Exxon realized what a problem they had. And I can tell you anecdotally, when I did this job for Disney that was sponsored largely by Exxon, they at that time were in the wind energy business, up into the middle of the 1990s. But they've gotten out of that completely. And did they do the right thing? Well, I just want to emphasize to everybody, to your students, that climate change has real costs. When you have floods, when you have to deploy emergency services, when people when they get their homes flooded, they can't go to work, these things cost money. And I don't know if anybody's from Wisconsin, but I know, Wisconsin, at least one person, yes, from Wisconsin. They have a thing every year where they park cars on the ice, and 12 cars sank through the ice because it was the warmest year on record, 2015. So what happens, not to get too complicated at all, the whole world's getting warmer, and superimposed on that is El Nino, this oscillation of temperature in the Pacific Ocean that greatly affects the temperatures in North America and South America. So we had a big El Nino, a warm year El Nino event, but that was superimposed on the whole world getting warmer, 2015 warmest year on record. And the reason I guess these guys stick with it is a quote I like to use from Upton Sinclair. It is difficult to get a man to understand something when his salary depends on him not understanding it. Now, I want to emphasize I'm talking about people who doubt and deny climate change. I'm not talking about school administrators. But if you look at people like Mark Morano or Joe Bastardi, they make their money from the fossil fuel industry. I mean, that's where their cash comes from. So on top of all this, people have, Joe Bastardi, who's from the Heartland Institute, wanted me to make predictions. You got to make some predictions, Bill. Oh, shoot, you got to tell us what's really going to happen. And yeah, so yesterday I offered to bet him $10,000 to take these two bets. I will predict that 2016 will be in the top 10 hottest years, and Mark Morano agreed with that. I also predict that 2010, 2020, this decade that we're in, will be the hottest decade yet. And those are predictions that I'm very confident in. And they're not, of course, just mine. These are climate scientists who can show this to be true. Then after this interview with him yesterday, hey, Bill, my nephew drew a picture of you. And can I have your picture? Okay. After we were butting heads for an hour and a half. Hey, can I have your picture? Sure. Yeah. Okay, man. It was funny to me. So as you may know, there's an organization doing a documentary about me, which includes you, and it's mostly David, Jason, Kate, the occasional Alicia. So if you see them wandering around tomorrow, and Tracy, if you see them wandering around tomorrow, please talk with them. They want to meet you. And you can be on camera, and when this film is released in February, you can be queen or king of the world. So with respect to climate change, you could very easily run in circles screaming, "Ah!" It's not effective. So there are organizations working very hard on this. And one of them is the Solutions Project. The Solutions Project is out of Stanford University mostly. And these are people that have done an analysis on each of the 50 states. It took about 10 years to complete the analysis on the whole world. And they have shown very reasonably that you could power all 50 US states with renewable energy in the next 30 years. You could get 80% renewable, they believe, in the next 15 years and 100% by 2050. And the other thing that they have done an analysis on, everybody, is the number of jobs you'd create. You'd create almost 150,000 jobs in Tennessee if you went to renewable energy to build all this stuff. You can't outsource the installation of photovoltaic panels. That's got to be done in the US with US workers. This is not extraordinary. You can't set up wind turbines in Sweden and then import them. Somebody's got to build them here at some point. And so the opportunities that we see in renewable energy are huge, or huge. And so, by the way, I was in Texas last week. Texas gets 10% of its energy from the wind. I mean, this is Texas, where it's just oil. And they are getting 10%, that's a huge fraction from the wind right now, without taking into account the future of photovoltaics. And so I submit to you, Tennesseans, that you could do the same thing here and get off of coal and have renewable energy, and you would have enough energy for everybody for the rest of our lives. Now, when I was in Texas, I was always also very gratified to see that Texas has this huge program to bring the space industry there. Whoa, Bill, to bring the space industry to Texas. And this is the Lynx spacecraft. It's being built by X-Corp. They used to be in California, but they moved to Texas because Texas is making it favorable to them. And they have a lot of wide open space. I'm very proud of that too. But the space industry is, all the money that's spent in space is spent on Earth, just so you're clear. And this is the spacecraft for $90,000. The plan is you can go fly in space for a few minutes and experience weightlessness and see the Earth from above. And I bring this up because I strongly believe that space brings out the best in us. Space is inherently optimistic, and it is the space technology that enables photovoltaics, that enables the internet, that enables mobile phones, that enables cable television, that enables everything. This technology derived from the space program. I mean, all the information technology that we embrace that allows us to compress files and share them came from, mostly from NASA. Yes, there's some Velcro, there's some Tang, but the deep impacts of NASA are much bigger than that. The word everybody loves nowadays is systemic. So with that said, I'm very excited to, at last, bring education to the forefront of the Planetary Society. And for those of you who, for some reason, are not members, which is weird, I strongly encourage you to join. And if you haven't met him yet, I want you to meet our own Bruce Betts.
Random Space Fact! Hey, here's a cool fact. Most of the youngest moon rocks are older than most of the oldest Earth rocks. Most moon rocks are between 3 and 4 billion years old.
That's all. Join us next week for another episode of Grandpa's Space Pants.
Dr. Betts.
Yes?
Bruce, it's not Grandpa Space Pants. It's Random Space Fact. Is this some dig against me because I'm old, because I have a lot of gray hair? Is that
No,
what this is
no,
about?
definitely not. No!
Well, then how do you explain this?
If you like this video, hit the subscribe button.
Yeah.
Bruce Betts,
Hey.
the man himself.
Thank you, Bill. So I wanted to briefly go over our random space facts and demonstrate some. We'll bring Bill back in a moment to help me demonstrate some things about space. But part of what I want to convey, as Bill did, is that space is a great thing to lead into all sorts of sciences, from physics to astronomy, but also astrobiology and chemistry. We may ask for the purpose, so what I'm going to do is first go over some fun facts here, and then we'll take a look at how you can get a hold of these videos free and online. But first, Bill, help me. Now you may have noticed that most objects in space, planets, other things, are spherical. Did you notice this?
I've seen pictures.
Okay. So we can ask ourselves the question, what if the Earth were the size of a basketball?
Oh, it's massive.
Then how big would the moon be?
I don't know, Dr. Betts. How big would the moon be? Oh, Dr. Betts got his PhD under Bruce Murray. Whoa.
That's where I learned to do this. Look, orbital dynamics. Ah!
Thank you, Bruce. That's a skill I didn't know you had.
I've been working on it.
So
All right,
wait, here's the question. I see where you're going with this. This represents the Earth. How big is the moon?
We got golf ball, tennis ball, softball.
It's
How
one
many
of those
people
three.
think the moon at this scale is a golf ball? Clap. How many people think tennis ball? How many think softball? Well, the correct answer is tennis ball. That was a tricky one. Now, I'm going to need your help here because the next question is how far away would the moon be? I want to give you the moon. But I'm going to need you to go out.
Would it be this far away?
No, you need to go farther.
This
Bill.
far away?
No, even farther.
Farther, like
Yeah, maybe you go out.
this
Yeah.
far away?
No.
Hi. Hi. Thank you.
No, you can just keep going. Okay, that's good. Just go right into the lap of some of those people in the front row.
Hi. Yeah, thank you. We have a moon chair.
Perfect. So, this is
How
a
far
model.
is this, Doctor? How far is this? in
I
meters?
assume you have gone exactly 7.2 meters.
Yes. Thank you.
Okay.
Let me back up just a little. There, yeah.
All right, then we can demonstrate rotation, Earth rotating in a day, and you can do some revolution of the moon. Keep it to one side, face towards the Earth. Oh, very nice. Very nice. Okay, so there's our, now it gets a little trickier when we go to the next question, which is when you talk about other objects, you talked a little bit about how far Mars is compared to
Mars?
other planets, but
Mars?
how about in this case? Well, first of all, how big would it be? It would be about the size of a shot put.
A
little bit bigger.
You have a shot put in it? Bruce, dude.
Let's just say I had to have some discussions with TSA.
Yeah, dude. Hang on.
All right, you ready?
No.
I've been practicing.
Yeah, good.
Ah! It's styrofoam.
Oh, it's so
the old
funny.
styrofoam shot put gag, the oldest one in the book.
Styrofoam moon thing.
All right, I got the
Mars
Earth.
thing.
I got the Earth. So that's how far the moon was. So
No,
now,
the moon 7.2. The moon was more here.
yeah,
This is out at
but
8.
it was you're right. You're right. That's a little bit farther.
Way-
but how
way
far
different.
Mars? How about you start heading out into space? What I like to call the audience. Yeah, just keep going. Then go. Smile for the pictures. And you're doing great. I'm just going to test out my other skills. Okay, keep going. Yeah, I'm kind of losing you in the lights. Let me know when you're at the back of the room.
I'm out in the icy vacuum of space, Dr. Betts.
All right, that's great. Now I need you to exit out the doors and go about 1 kilometer away.
All right, I'll see you in a little while.
All right. Really? Well,
Door won't open.
all right.
I'll be out here.
Okay, so
1 kilometer. Here I go. I'll be right back.
All right, he'll be right back. I'll just give him some more facts while you're headed out a kilometer. I didn't really think he'd go. Well, we've got some time to kill. So on this scale, the Mercury would be about this size, about the size of a softball. And Venus would be a little bit smaller than a basketball, fairly similar in size. Bill, you can, if you can
Is this far enough?
Yeah, that's good enough. You can go ahead and head back to the stage.
There's a wormhole.
Oh my God, that was amazing. Wow.
I
Bravo.
just got projected right back here. It's all so familiar, but I feel somewhat older. 2 or 3 minutes
Time
older.
travel humor. Okay, you can give me back Mars. And now, after your journey of what I need you now, it's hard enough to do planetary scales. But now we're going to do stellar scales. So what I need is, I'll need you to run this time. So first we're going to do, okay, good. We're going to set up a whole new scale. The entire Sun to Neptune, which is 30 times the Earth's,
the 8th traditional planet.
Yeah. What I need you to do, here, come over here to, now our Earth is just a speck. Our Sun, we'll start with the Sun. I need you to run.
Run.
3 steps that way, 3 big steps.
Pretty compelling,
half
huh?
a fourth, yeah, okay. Okay, perfect. You have now, congratulations, you've run all the way from the Sun to Neptune on our new scale.
Oh wow, we've compressed.
We changed things a lot.
Yes, you take
because now we're
the
trying
telescope and turn it around. Yeah.
Yeah, you can look at it that way. So now the question is, how far on this scale, Sun, Neptune, how far is it to the nearest star, Proxima Centauri? How far do we have to have Bill run this time? I'm going to give you 4 choices. All the way
this
from
is 30 astronomical
30
units.
AU.
30 AU.
30 AU is here. How far to the nearest star? We'll go from a 100-meter dash to a marathon. Does Bill need to run a 100-meter dash? Okay, how about a 1 kilometer run? 1K. 10 kilometers. By the way, clap if you think it's the right answer. All right, marathon, 42 kilometers. That is correct. Are these science teachers?
Yeah, some of them.
Oh, pretty impressive.
42 kilometers.
Yeah, so here to there, Sun, Neptune, you have to run a full marathon to
get to the nearest star.
So you can go ahead and run the full
right.
marathon.
See if I'll try to break my.
All right, you go do that.
record.
Meanwhile, let's show another video. See if I can work the computer here.
No, I got to jump back on.
Bill,
What am I doing? Yeah.
Bill.
Gently. Steady.
Commercial airliners have a cruising altitude about 10 kilometers above the surface of the Earth.
but I want to go a lot higher. 3, 2, 1! We are now at the altitude of the International Space Station, 40 times higher than a commercial airliner's cruising altitude. But I want to go even higher. 3, 2, We're now at the altitude of geostationary communication satellites, 100 times higher than the International Space Station, and 1/10 of the way to the moon, which is where I want to go next. 3, 2, 1. Oh, we are now at the altitude of the orbit of the moon, 40,000 times higher than a commercial airliner's cruise altitude. Another little random space fact. Apparently I get space sickness. I might need to use this, so if we could just cut now, that would be great. Can we go home now?
So these random space fact videos are roughly, this had a few more, but roughly one fact, one laugh, 1 minute, highly refined humor, as you can tell. I started doing these many years ago when my neighbor was very interested in space, but had the attention span of roughly a second grader. And so I'd package these gee whiz space facts for him, get them in. Then I found other people like gee whiz space facts. So it went from email to our weekly radio show to Twitter, where I'm at Random Space Fact, and then now these videos, which we have we have 44 now online. They are free, they are online. You can grab them at this webpage, which is planetary.org/RSF. You can either get them one by one, check out what they are, or download them all. We have 44. They range in topic. We have an info data sheet you can get, so if you want something about Mars, or you want something about phase changes, or something mathematical, you can get that. And we'll also have a sheet with some suggestions for classroom use. This part's a little repetitive with Bill. Basically, we found that kids tend to love space, and planet and space studies involve all sorts of sciences, as you can see, whether it's volcanoes on Mars, atmosphere on Venus, math, physics, science, history. We have some of those, chemistry, astronomy. Here, we have, as I say, online some suggestions for classroom use. You can use it just to introduce a topic, scale of the solar system, Mars, state changes. As an example of the usefulness of some topic you're teaching, like exponents, map scale, as breaks. So there are no teachers who use it just, they've got 5 minutes left before recess, so they'll plug in a couple of these. Kids get a little bit of content, a little bit of fun before they move on, or extra credit. But what we really want is we also want your ideas. If you find these useful, what are good ways to use them? Also, on my Twitter feed, you can see things like this, pictures where I shamelessly include a picture of one of my sons. And if the Earth were the size of a soccer ball, Jupiter would be the height of a soccer goal. All right, so here's where you can get them. Planetary.org/RSF, Twitter, Random Space Fact. Please, 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 as Whitney has said and Bill has said, come to our booth, 1012. Scan your badge to join Bill's STEAM team. And right now, for those of you who have access to the internet, you can tweet your questions for Bill and the rest of us to answer at the end of this program. Use the hashtag STEAMteam. You can also email any classroom ideas to rsf@planetary.org. Here's one more Random Space Fact video, and then we'll bring you back to Bill Nye, the Science Guy. Random Space Fact! From a dark sky
you can see about 2,000 stars. But that's just a teeny tiny fraction of the total number of stars in the universe, which is estimated to be about 7 times 10 to the 22nd stars. That's 70 sextillion stars. That's 7 followed by 22 zeros. Sorry, my car. Got it. If you like this video, hit the subscribe button. Yeah.
Yes, yes. So Dr. B will be at the booth tomorrow. Dr. Betts will be at the booth tomorrow. So we'll take your questions. I know people are tweeting, the kids with their electric phone machines. So I just want to wrap up this part of it by reminding everybody what's possible. These are the twin beams representing the Twin Towers over New York City after 9/11, memorial to 9/11. I was flying over New York this year and I took that picture. I mean, I was in a plane. I wasn't just not like that athletic, but it was a tragic thing. It was. Everybody was very, very concerned. Everybody's very concerned about the future of the United States, the future of the world, and so on. We've steadily been working our way through that, and of course, we're still working our way through it today. But in order to accomplish things, I strongly feel that no matter what conflict's going on, we have to be optimistic. And I think about my grandfather, who was in World War I. I have no evidence that this is my grandfather, but looking at his stuff, his uniforms, and so he was dressed like this at some point. He went into battle on a horse. He wore a gas mask and he put a gas mask on his horse. And for those of you who are animal lovers, the horse's gas mask has no eye protection. I mean, horses were just treated like machines back then. And I think you can get a sense of that. I mean, the horse is remarking, I don't speak horse talk, I'm interpreting, that it wasn't going to work out so well for him. But 20 years later, everybody, 20 years later, anybody who went into war did not do it on a horse. Everything changed. This soldier standing on a horse trying to shoot a gun is remarking, this is hard. And then the horse, I think, was thinking, dude, really? Dude. If you're on a horse and you see a tank, you go the other way. And so everything changed in just 20 years. Everything changed. And so when I meet people, as I met yesterday, people who think we can't do anything about climate change, we can't achieve great things again. We could never send people to the moon. We could never build something like Hoover Dam or Grand Coulee Dam. We could never do these big ideas and carry them out. I say, yes, we can. These people are this is my parents. Oh, it's a picture of my parents. They weren't that big. They came of age during World War II. My dad was a prisoner of war, and my mom was a cryptographer for the U.S. Navy. And for those of you who have not seen this picture before, it's one of my favorites. That's my mom. And I have to say, my whole life, she was very good at puzzles. I will give you that. And she was recruited to work on the Enigma code. And I'm just being objective here, everybody. I'm not a bad person. When I look at this picture, really, who has the best legs? Okay? I'm just saying. And I think that an image like that in his head kept my dad alive through the trouble. But they both lived through it. And in 4.5, 5 years, people of that generation changed the world. They saved Western democracy, and we have the quality of life that we have now because people just stepped up and got her done. And it was people of all walks of life working all the time often day and night, to outproduce the enemy and win the war. And this led to these series of posters you've probably seen with Rosie the Riveter and You Buy 'Em, We'll Fly 'Em, talking about war bonds and victory gardens and stuff. So I want you to create the next great generation. I want your students to work together to become scientifically literate, to appreciate art, and dare I say it, change the world. Thank you. Now, you've probably heard that Carl Sagan was this young guy, this enthusiastic guy who pitched this idea that if we're going to send spacecraft out of the solar system, out into the cosmos, let's put a message on them. Like in the same way you put a message in a bottle and throw it out into the ocean in the hopes that somebody in Papua New Guinea or some exotic place will find the thing and say, Bill, hey, I found your bottle. Cool, do you have the internet? You wouldn't need to, yeah, okay. But it's exciting, and when you do that, when you put a message in a bottle, when you put a message on a spacecraft, you're doing it for yourself. Yes, it would be great if somebody found it, that'd be fabulous, and wrote back to you. I hope they don't write back to you by means of bottle. I hope it's some other technique. But it's fantastic, because when you put this message in a bottle, you're being optimistic. At some level, you're hoping that somebody will find it and that they will know about you and your life. And so what you put in the bottle is of great interest to you. And so Carl Sagan and his colleagues took a lot of time to put a message that any alien could easily reckon using the hydrogen atom vibrations and binary symbols. How hard could it be? But it brought out the best in people. People all over the world were commenting on it. Today, there are 3 rovers on Mars, and the rovers have a very small instrument called the photometric calibration target. It's the test pattern for the cameras. And each of them has, in very small writing, a message to the future. Written on each spacecraft, if you know where to look, it says, to those who visit here, we wish a safe journey and the joy of discovery. And that, my friends, is the essence of our business. That, my friends, is the essence of science, is to do investigations and feel the joy of discovery. Do you see the Earth? It's right there in this view. I guess that's pretty obvious. But I think if we work together, if we get kids excited about space and dinosaurs, and how we know how carbon dioxide interacts with sunlight, how we know how the world's ocean circulates, how we would go about looking for life on another world. If we work together, I claim that we can raise the next great generation and change the world. So thank you all very much for sitting through this much of it. Now we're going to take your questions. Thank you. Thank you. Thank you. Do we have, oh yes, here they are, 2 microphones. They're up here on, oh, you guys, so this is Andrew and Kate.
Hi guys, I'm from Wisconsin. I was that guy who yelled earlier.
Yeah.
Go Pack!
And
I'm
Kate's,
from Montreal. I'm the person with the awesome $5 bill.
Awesome.
hold
cool.
on, was that the thing? Let's go to this.
No.
There we go.
No, but it
They're
was a
out of
groovy
order,
tune.
but there you are.
Awesome. I guess I'll do the first question. Question from Patrick Goff on Twitter asked, Bill, how can we get legislators to understand the importance of a scientifically literate society?
You can't run in circles. No! What we do at the Planetary Society is advocate for you. So we have a whole scheme now to show you how to advocate, how to send emails and letters to your representatives, how to encourage him or her to do the right thing. And it's strangely influential when you send targeted emails. And I use the word targeted, meaning We do analysis to figure out which district you're in and to whom to write and what you should say. So we are working on that. Advocacy is a big part of our mission. And so we are here to help. We're doing our best to help. And of course, you consider joining the Planetary Society. Yes, Kate.
All right, next question came from Ashley Kemper. Are our curriculum models now similar to the Ford Pinto model, or do you think we're on the right track?
What models?
The Ford Pinto.
What about, what's the one,
Well, the curriculum models.
curriculum models?
How's it going with science education?
Well, I'll say this. When we worked on the Science Guy show, starting in 1992, we worked really hard, and it says in our objective that we hope someday people would follow our curriculum, because at that time, standards were emerging. The Common Core had not been invented yet. There was no such thing as No Child Left Behind. I know you all love it, but yeah. And I'm kidding, ha ha, can't hear me. But we worked very hard with a lot of educators to get this thing focused. So the big deal is we're here to provide you with what we think are going to be really strong curriculum materials. And I claim we're going to spend a lot of time on the design, and that's where you come in by coming by the booth tomorrow to give us an earful. Please, lead on.
Tracy asks, are asteroids enough of a threat that we should even worry about them?
Heck yes. There is no evidence, none at all, that the ancient dinosaurs had a space program. They might have, and we just don't even know about it, right? I mean, maybe they were really sophisticated and they had art and museums and they had zoos full of little mammals. But they probably didn't, and it only takes one. And so we are the first generation of humans that could build a spacecraft that has the astronomical capability to find asteroids and do something about it. You know, as we say, looking for an asteroid is like looking for a piece of charcoal in the dark. They're difficult to find, but nevertheless, there are techniques. And so we want everybody in the world not to drop everything and start driving on the left side of the road. Just asteroid detection and deflection is something that humankind is going to have to do sooner or later. Yeah, it's definitely, there are over 100,000 Earth orbit crossing asteroids that would be huge trouble. But there's so much space in space that we seldom get hit. Yes, Kate.
So another question that we got from a number of people who apparently are very upset about this. What happened to Pluto? Why isn't it a planet anymore? Can it become a planet again?
Pretty please.
Well, naturally, I'm in charge. No, I'm not. I'm not, but everybody in astronomy, you know, they're crazy for this. They have stars. They got white dwarfs, they got red dwarfs, they got brown dwarfs. They like dwarf. Now, you know, you can ask, is a dwarf human not a human? And of course he or she is. Yes, what are you talking about? So they made up this term dwarf planet because it's less than 1,500 kilometers across and it has to clean out its orbit gravitationally, and it's kind of done that. And it has some objects that are in its vicinity that apparently are just about almost as massive as Pluto. So they came up with dwarf planet. If I were king of the forest. I like the word Plutoid. I think that's cool. So the way you may, I work hard to be diligent. I'm sure I mess up sometimes, but I try to say ancient dinosaurs when I'm talking about the ancient dinosaurs, because we still have dinosaurs today. In fact, our national symbol is a dinosaur. The birds are dinosaurs. Cool, fine. Ancient dinosaurs, I think you know what I'm talking about. And I look at an Allosaurus, I don't think, wow, that's a sparrow. No, I mean, with that said, I like to say there are 8 traditional planets. Traditional planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. What's not to love about that? So Pluto, instead of being the last of the traditional planets and getting this controversial adjective dwarf. How about it's the first of a new class of objects, the Plutoids, and Sedna and Quar and all those crazy places, and Charon, they would all be Plutoids. Come on, Bill. Wow. But as is often the case, and you can ask anybody on the staff of the Planetary Society, my genius has not been recognized. So we'll see. Just bear in mind, if there are any Plutonians, they probably aren't that concerned that Earthlings really don't get it right. And you can remind your students. For those of you who can't get over this, that we learned more about Pluto and its place in space and we changed its designation, for those of you who can't get over this, I have some advice for you. Get over it! Yes. Andrew.
All right, this next question is for you and Dr. Bruce Betts.
All right.
If he'd like to shimmy on out here. Dr. Bruce Betts, everybody, woo! He's back. All right, so this question is for you and Dr. Betts. What do you think is the biggest hurdle we humans have that we must overcome to get to Mars?
Agreeing to do it. That's the biggest hurdle. It's leadership. Now, what I like to say about the Planetary Society is we are not crazy. I was quoted saying that in Space News, for those of you who somehow missed your last issue of Space News. No, that's really the name of it. What's the name of it's called Space News. Oh, so it's the news of space. Wow, that's brilliant. You know, it's not called Chronicles or it's just, anyway. You meet a lot of people who think that we should drop what we're doing in the space program and put all our resources in going to Mars and demand that their state have a space center that is the focus and all the money will go there so that we can go to Mars. Meanwhile, there are people who want to do heliophysics. There's people who want to look for exoplanets. There's a lot of people pulling NASA all different directions, but generally what happens, these people, our representatives, can't quite agree on what to do. So we at the Planetary Society are working hard to be a leader. There is a program to get to Mars in the next 15 years, or rather 17 years, if we just decided to do it. Now, this position or this way the space program in the United States is treated nowadays has come to be called the Nixon Doctrine. So after people landed on the moon successfully, and Apollo 13 almost killed some people in a spectacular way, the President Nixon felt that public interest in space exploration was waning. And he was largely correct. So it was his idea to really make NASA just another line item in the US government budget. So during the height of the Apollo era, the NASA budget was 4% of the federal budget, 4%. Today, the NASA budget is right around 0.4%. It's right around a tenth of what it was. And by the way, and I think the Planetary Society takes full credit for it, the NASA budget has been increased for the first time in a long time. It's now over $19 billion. So we have a diligent program, and as the old saying goes, Washington is a small town based on relationships. So you just gotta, the kind of people that support space, it's amazing. This guy loves trees, this guy hates trees. But when it comes to space exploration, they work together. It's something. So all we have to do is agree to do it. And we could get in orbit around Mars in 2033, land there 2037. I very much hope to be alive for it. Get to work, people. Yes. Bruce, comment. Come up to the microphone or not. Oh, you have one on. Crazy.
I have one on, and it works. So I'd concur, summarized as political will. That's what's required to get humans to Mars. Obviously, there are technological issues, particularly understanding how to keep humans alive in deep space in a high radiation environment.
Keep them all alive? All of them?
Well, political will. one great thing about the orbiting is landing large payloads on Mars very, very hard. And then finally, I will conclude with noting we haven't had humans on Mars, but we have a very robust program of our robotic emissaries exploring Mars in a virtual way for us now. But there you go.
By the way, the planetary science budget within the NASA budget is 9% of the 0.4%. It's about $1.5 billion, and we have managed to get up over $1.5 billion for the first time in a long time. And with that, we do all this cool stuff. Mission to Mercury. This summer, there'll be an orbiter around Jupiter called Juno, named after Jupiter's wife. Got the 3 rovers. 2 rovers are still running on Mars. By the way, Spirit, the rover named Spirit, ran for 6 years before it quit. 6 years, and that thing was designed to run for 3 months. So 6 years, it's like having a car with a 3-year warranty, not changing the oil, not rotating the tires, and having it running 120 years later. That's your tax dollars at work, people. They do extraordinary stuff when we let them. So
there are five orbiters working on Mars right now as well.
And that's done for a song. And now people, the Indian Space Research Organization has MOM, Mars Orbiting Mission, and ExoMars is on its way. You can only go to Mars every 26 months because of the orbits. Yes, lead on.
All right, I'm going to keep going with the space theme. We've got apparently not only teachers here, some children have snuck in and are asking questions, so
I'm
find them.
shocked.
This one comes from Dakeen Lee, who is 11 years old.
I was 11 for a while.
What do you think space science will be like when I am my dad's age? Or better yet, your age?
I don't know if anyone's that old. We hope you will have gone looking for life on Mars. Here's what I hope. Keenan, what's?
Oh, I'm going to have to look it up again.
Oh, sorry, no, the person with a name who's 11. Say again?
Dakeen, right over there.
Yeah, hi. We hope that we will have looked for life on Mars, and I frankly hope we've found life on Mars. I frankly hope we will have explored Europa, this moon of Jupiter, and gone under the ice with an instrument, a gizmo, a spacecraft, an icecraft that can sniff around for life. I mean, it's very reasonable to me that under the ice, where there's liquid, it's kept liquid by the gravitational squeezing of its orbit around Jupiter. And you can see Europa with a telescope, a modest telescope, or with binoculars, if you're really powerful binoculars, but with a regular telescope like Galileo used, 30 power, you can see the moons of Jupiter, these 4 big ones, and you can see Europa. And so I always say, in 100 years from now, people will know whether or not there's life on Mars. People will know whether or not there's life on Europa. I want to find out now. I want to get her done. So if you're 11 now, here's something I want you to think about. If you want to be an astronaut, every time you sit down to eat, ask yourself, what would an astronaut eat? Would an astronaut eat junk food? Or would an astronaut eat healthy vegetables? When it's time for you to go to bed, would an astronaut stay up all night whining? Or would an astronaut go to bed? Would an astronaut mess around and not do his homework? Or would an astronaut buckle down and learn algebra and become an astronaut and make a discovery that would change the course of human history? So get to work. Yes. 3 more, I think.
Sounds good. Brittany F. asks, how can we empower our students with the science that their parents deny?
Whoa.
Right?
That is a hard one, because I know we're in Tennessee. No, it's really hard. But I just, how to say. Evolution is the fundamental idea in all of life science. And the guys who discovered it didn't even know about DNA. And you are living at a time, your students are living at a time when it's very reasonable to me that almost all the forms of cancer that we are familiar with, the one that killed my mom and the one that my dad recovered from for many years before he died, those types of cancers will be treatable routinely. It's very reasonable to me. And that cancer treatment would be a result of our understanding of biology, and part of that is our understanding of evolution. So along that same line, keep in mind that the evidence for climate change is overwhelming. It's overwhelming. It's more than 97% of the world's scientists. For those of you who have to deal with people who think there's a conspiracy, just remind you that conspiracy theories are kind of lazy. If only there were 60 people running everything, and we just find their office and unplug their computer, and we'd be fine. No, this scientific consensus has come from all over the world. So what I would say to you, if you're really confronted with this, is let's advocate for education policies that support accepted science. It's all I mean, we just have to fight this fight. You know, when I was in school, when I was a little kid, people were still not absolutely sure about plate tectonics. But plate tectonics is the fundamental idea in all of geology. And when it comes to, and it just took time. As we say, science progresses by way of funerals. As old scientists who think in the old ways die off, people make progress scientifically. That's not my idea, that's an old saying. And so I have found that climate change denial and denial of evolution is almost entirely generational. You have to look really hard to find a young person, a millennial-aged person, who doesn't accept and is not concerned about climate change. So we got to fight the fight, everybody. We got to change the world.
Okay, this question comes from Hannah Penn.
Oh, thank you.
Yeah,
Yes,
yeah.
thank you. Yes.
All right.
Very good.
All right, this question, if you had to choose, what would be your favorite planetary body? And then, because she doesn't want to let you get off too easy, she adds, please support your answer with evidence.
Cool. I have an answer. It's not glib. I want to live where I can get clean water, reliable electricity, and access to worldwide information, to the internet. I want to live where I can breathe. I want to live where there's food. And so my favorite planet, absolutely without question, is the Earth. I'm sorry, people. When we have the solar system cup, and it's Earth versus Saturn, I'm still Earth, man. I'm Earth all the way. I mean, I'll respect the contest with the Saturnians, but I'm about Earth. And you know, people who think in the sort of colonial model that, well, we'll just go to Mars to live on Mars. After we destroy this planet, we'll just go to another and we'll terraform it. Just take a few minutes, set up camp. It's not like that, everybody. The Earth is the only place humans can live. Oh, yes. If you really want to live on Mars, go to Antarctica for a couple years. And, you know, let's play fair. Don't go to the ice shore where there's penguins jumping and krill and whales and orcas are doing this. No. Go to the dry valleys where it hasn't rained or snowed in 100 years. See what you think. And then also, just to play fair, take all the scuba tanks full of air you need for 2 years and see if you think that's for you. The Earth is it, everybody. This is where we make our stand. This is where we have to work together to provide this high quality of life for all humankind. Yes. Last question. Hold on, who started? Did you start or did Kate start? Second, penultimate question. Kate, you're going to get the last one. I'm revising. Yes.
All right, then I'm going to ask this one. Scott Rico also asks, he is 10, and so it's another...
You're 10, way to go. I was 10. I did that before I was 11. I did.
Scott asks, I am 10. What is pure science, and how would you define it for me?
Ooh, I love you, man. So, Pure science is when we discover nature's laws, when we discover how nature works. And we do that through this process where you make an observation. You're sitting and thinking, you're walking and thinking, and you see something, you hear something, you smell something, and you come up with what you think happened or happens to create that situation, the sound of what you see, what you smell, hear, or taste. And so that's what we call the hypothesis, the idea below, hypothesis. Then you come up with a way to test that hypothesis. You test it, you see what happened and compare it to what you thought would happen. And then you come up with another hypothesis. And do you know when you're finished in science? You're never finished. And some people, I will tell you, 10-year-old person, man, what's his name? I lost it already.
Scott,
that's right. Scott, I will tell you, some people are very troubled. They're unsettled that we don't know everything. Other people, shown here, are excited that we don't know everything. We celebrate the idea that there's so much more in the cosmos, there's so much more in nature to uncover and learn about. Because I guarantee you, when we explore, we will make discoveries. Two things happen. You make discoveries and you have an adventure. So the process of science for people like us and the people who are professional educators here in this room, Scott, the process of science fills us with joy every day because every day we make discoveries and we have an adventure. Way to go, man. Last question. This is it.
All right. Last question comes from Lauren. How do we inspire girls to go into the science fields?
Great question. How do we inspire girls and women? So the reason it's important, first of all, if we had as many women in science as we have men in science, we would have twice as many brains. Okay, ladies, yes, more than twice as many brains involved in trying to solve the world's problems. And let me say that's really important, and I didn't do this study, but I found it very compelling. We have to get all of our students engaged in algebra. Algebra is apparently the single most reliable indicator of whether or not you pursue a career in math and science. It's not clear that it's cause and effect, but it's people who go into professional careers as scientists or engineers liked algebra enough to stick with it. Apparently, algebra enables you to think abstractly, not just about numbers, but about all sorts of things. So I strongly encourage all science teachers to encourage the math or the arithmetic, whatever it is, in all of your investigations. And what we want to do is get students thinking about symbols to represent numbers just much earlier than we have traditionally. And there is that point in middle school, and I'm not telling you know nothing, where girls are just better at everything. And so we've got to embrace that. Because the key to our future in humankind is to raise the standard of living in women and girls. We'll have twice as many brains, we'll have fewer, better cared for children, and we will solve problems on a global scale. That is a great question. Thank you all very much. Thank you. Come check us out at the booth tomorrow, and we'll work together to change the world. Do I press the button now?
Random Space Fact!
See you tomorrow.
Every day, more than 100 tons of dust and sand-sized material hits the Earth's atmosphere at high speed, burning up and forming what we see as meteors. About once a year, a car-sized asteroid slams into the top of the Earth's atmosphere at high speeds, burning up in a massive fireball, although typically burning up completely before reaching the Earth's surface. We want to show you what that looks like. So let's go ahead and take the asteroid up. Go ahead and take it up. Go ahead and... No, not my car, not my car! I just got the windows fixed! No! Ah! Want to learn more about planets and astronomy? Check out my free online course at California State University Dominguez Hills, Introduction to Planetary Science and Astronomy. Go to planetary.org/betsclass.